Bamboo has been used in construction for thousands of years. So why is architecture talking about it again now? For centuries, bamboo has been used to build houses, bridges, roofs, and community structures across Asia, Latin America, and Africa. Yet today, bamboo is returning to architectural conversations as architects reconsider how we build and what materials we choose. As the construction industry looks for ways to reduce its environmental impact, bamboo is often presented as a renewable alternative to more carbon-intensive materials. It grows quickly, can store carbon while it grows, and many species regenerate from their existing root systems after harvesting. Because of this, bamboo is often seen as a symbol of sustainable architecture. But that's only part of the story. Bamboo isn't just a building material. In this edition of ArchDaily's Architecture 101, we'll explore the knowledge behind it. So, how has bamboo remained one of architecture's oldest and most relevant materials? One reason is powerful yet simple: geography. Bamboo grows naturally in tropical and subtropical regions, where more than 1,400 species can be found. Unlike many traditional timber species, some bamboo varieties reach structural maturity in around 3 to 5 years. Its hollow cylindrical structure also gives it an exceptional strength-to-weight ratio, combining lightness with remarkable structural capacity. Together, these qualities helped bamboo become a practical building material long before industrial construction existed. As a result, bamboo became closely connected to local building traditions around the world. In countries such as China, Japan, Colombia, Indonesia, and India, builders developed construction techniques adapted to local climates and available bamboo species. Over generations, this knowledge evolved through continuous observation, experimentation, and practice. Rather than forcing the material to behave in a certain way, they designed around its natural properties. In regions such as northeastern India, where heavy monsoon rains are part of everyday life, builders developed strategies adapted to these conditions. This meant lifting buildings off the ground, extending roofs for better protection, improving airflow, and finding ways to protect bamboo from moisture. The material's success did not come from resisting nature, but from understanding it. So if bamboo is such a remarkable material, why don't we see it everywhere? Part of the answer is that bamboo doesn't behave like industrial materials. Unlike industrial materials such as steel or concrete, natural bamboo culms are not produced with uniform dimensions. No two bamboo pieces are the same. Their diameter, thickness, and shape vary depending on the species, where they grew, and even when they were harvested. This natural variation is what makes bamboo special, but it also creates one of its biggest challenges: fitting into a construction industry built around standardization. One architect widely recognized for exploring this approach is Simón Vélez. Working primarily in Colombia, Vélez demonstrated that bamboo could perform at much larger scales than many people expected. Projects such as the Ziri Pavilion, built for Expo 2000 in Germany using guadua bamboo, showed how engineered bamboo structures could span large spaces while celebrating the material's geometry. Rather than hiding bamboo's irregularity, the project embraced it as part of its architectural language. Taking a distinct perspective, Japanese architect Kengo Kuma approaches bamboo through a lens of lightness, rhythm, and spatial delicacy. In projects like the Great Bamboo Wall near Beijing, Kuma uses bamboo not just for raw structural support, but as a subtle filter for light and air. By arranging slender bamboo stalks into rhythmic screens, he blurs the boundary between the building and nature, proving that the material can be as poetically minimalist as it is strong. Another important example is the work of Alora Hardy and the design studio IBUKU in Bali. Their buildings combine bamboo with traditional craftsmanship and digital design tools to create schools, homes and community buildings with sweeping roofs and highly expressive structures. Projects like the Green School and Sharma Springs show how bamboo can shape an entire building, from its main structure to its interiors and furniture. These projects are often recognized for their dramatic forms, but behind those forms is a deep understanding of harvesting, treatment, joinery, and long-term maintenance. While engineering has expanded what bamboo can achieve, many of the techniques that make it successful still rely on generations of accumulated experience. Rather than competing with one another, craftsmanship and engineering are increasingly working together. It is becoming part of conversations about engineering, sustainability, and new ways of building. But bamboo's contribution goes beyond how it performs as a material. It also changes the way architecture thinks about time. Many buildings today are designed to last for decades, even when the activities they contain may only exist for a few years. Retail spaces change. Exhibitions come and go. Temporary pavilions are assembled for a single event. Yet many of these projects are still built using materials intended to last for generations. This reflects a long-standing idea in the Western world, that permanence and resistance define quality and good architecture. But bamboo suggests another way of thinking. Because it grows quickly, is lightweight, and can support adaptable construction systems, it can be particularly suited to buildings designed for change and repair. That doesn't mean bamboo should take the place of steel or concrete, or be transformed into a standardized product to fit today's construction systems. The more interesting question is different. Are we always choosing materials that match the lifespan of the architecture we're creating? Perhaps bamboo is most valuable not because it can solve every construction problem, but because it encourages architects to think more carefully about permanence. Not every building needs to become permanent infrastructure. Some are designed to evolve, to be adapted, or eventually dismantled. In those cases, bamboo offers a material logic that aligns more closely with change. Innovation doesn't always come from inventing entirely new materials. Sometimes it comes from rediscovering knowledge that has existed for centuries and combining it with contemporary engineering. Today, bamboo sits at the intersection of tradition and technology. It connects vernacular knowledge with modern construction, craftsmanship with engineering and local building cultures, with global conversations about sustainability. Instead of asking whether bamboo can replace concrete or steel, we should ask, how can we learn from vernacular knowledge to build a more adaptable and responsible architecture today? Tell us, what's your favorite example of bamboo architecture? Join the conversation and share your thoughts in the comments. If you want to keep exploring these topics, don't forget to like this video and subscribe to our YouTube channel. You can also discover more episodes of Architecture 101 on ArchDaily through the link in the description. See you in the next episode of Architecture 101.